Hi guys, welcome to another video of Physics 2. In this case, we're going to start with a topic about statics. And in order to explain this topic, well, I'm gonna do it with a problem. And this is the problem over here. This is a roof, okay? So attached to the roof, there are two wires. These blue wires, this one over here, and this one over here. So they are holding a block which mass is 10 kilograms. Okay, so I have three wires, and those wires, they need attention in order to support this body. Okay, so I have the tension 1 and tension 2. So if you see, I have this little wire over here, but that is not it's going to be neglected because the wires that produce the strength in order to hold this block are tension 1 and tension 2. Okay, so one important thing about statics is that the object is not going to move. So we can say that the system, this whole system, is going to be imbalanced. So in order to have a system imbalance, the sum of all forces must be equal to 0. Okay, so that means that the resultant force equals 0. So if the force is 0, that means that there is no acceleration. Okay, the acceleration is 0. So if the acceleration is 0, there are two things that we can think about. Okay, the object moves at constant velocity, or the object is at rest. Those are the two choices that we have. If the resultant force is 0, so that means the acceleration is 0. So if that's the case, there are two things that we can have: constant velocity, or that the object is at rest. In this particular case, when we talk about statics, the object is at rest. Okay, so in this problem, the main questions are: what will be the value of tension 1 and what is the value of tension 2 in order to have the system in balance? Okay, so now that we explained this about statics, that every system is going to be in balance, so that means the resultant force is 0. Okay, now what we have to do is to draw the free body diagram. And remember that the free body diagram is a Cartesian plane, just like this one that I'm drawing. Okay, this is X and this is Y, and in the center of the Cartesian plane I'm going to draw a particle that is going to represent this object over here. Okay, so remember that there is always a force that, okay, they don't mention, but it's always there, and that force is the weight. So I'm gonna make a drawing. This is the weight. Okay. Now I'm going to represent the tensions. So I'm gonna have this tension over here, that is tension 2, and another tension over here, that is tension 1. Okay, so remember that we don't want those tensions. We need the rectangular components, because those rectangular components are over the x and the y axis of my Cartesian plane. Okay, so in order to do that, well, I need this little angle over here, and I need this little angle over here. So if you see the drawing, I don't have that angle. So I'm gonna make an imaginary line, horizontal imaginary line. Okay, and I'm gonna draw something like this. This is the line, and I'm going to continue the line over here. Okay, so this is the angle that I want, and this is the angle that I want. Okay, so how can I get that angle? Well, there are many things that we can do in order to get that angle. So I'm going to show you one way to do it. I'm going to erase this because it's going to obstruct the writing that I'm going to do. Okay, so I need to get that angle. So what I'm going to do, I'm going to draw this imaginary vertical line. So if you see over here, I got a right triangle, and the right triangle has a 90 degrees angle over here. This is a 90 degrees angle, and I have another angle over here. So if you see, if I add this angle and this angle, I'm gonna have a 90 degrees angle. Okay, so I already have 30 degrees. So how many do I need? I need 60 degrees over here. So the sum of those two angles is 90 degrees. So remember that there is some principle about the triangles that said that the sum of all the interior angles in a triangle is 180. So I got 90 plus 60 is 150. So I need 30 degrees in order to complete 180 degrees. Okay. So this is one way to do it. Another way to do it is, for example, if you see this angle over here and this angle over here, they are alternate interior angles. So I hope you remember from math that alternate interior angles are exactly the same. So that means that this angle is 15 degrees. Okay, I repeat, this angle and this angle, they are alternate interior because there are two parallel lines, this line over here and this line over here, and they are being cut by this transversal line. So that is another math principle. Okay, I repeat, there are many ways that you can come up with this angle and this angle. Okay, so now that we have those angles, well, I'm gonna write them over here. This is a 15 degrees angle and this is a 30 degrees angle. Okay, so let's continue. Remember that I don't want those vectors, tension 1 and tension 2. I want the rectangular component. So I'm going to have a vector that goes to the left, that is tension 1 x, and one that goes to the right, that is tension 2 x. And also I'm going to have one vector that goes up, that is tension 1 y, and another one I'm going to draw it with another color, that is going to be tension 2 y. Now, one important thing about this problem, if you remember, the previous topic was dynamics, okay? And in dynamics, the block was over a surface. So every time that the block is over a surface or on a surface, the surface is going to have a force, a reaction force over the block, and that reaction force is called the normal force. So now in this case, if you see, the block is not in touch with any surface. So in this case, in this particular case about statics and this particular example, we are not going to have normal force. Okay, so let's continue, guys. Let's solve the problem. So let's start with the analysis of x and y axis. So first, x axis. So remember, I told you the sum of all forces in this case is going to be 0. So the sum of all forces in x equals 0. So everything that goes to the right is positive. In this case, tension 2x, and tension 1x goes to the left. So it's going to be negative. Okay. So I'm going to have tension 2x minus tension 1x equals 0. I'm going to isolate tension 2x. So tension 2x equals tension 1x. And I'm going to continue with the substitution. Remember that tension 2x and tension 1x, I need the cosine. Okay, so tension 2 times the cosine of the angle of the tension 2 equals tension 1 times the cosine of the angle of the tension 1. From this equation that I have here, I'm going to isolate the tension 2. So cosine of the angle of tension 2 is going to move to the other side dividing. So tension 2 equals tension 1 that multiplies the cosine of the angle of the tension 1 over cosine of the angle of the tension 2. Okay, so can I solve this equation? Well, I don't have tension 1, but I do have the angle 1 and the angle 2. So, well, I cannot solve this equation. So I'm going to stop. I'm going to stop a little bit over here, and I'm going to continue the analysis of y-axis. So let's do it. Y-axis. So all the forces that points up are going to be positive. So I'm going to have tension 1y plus tension 2y minus the weight equals 0. Then I'm going to remove the y and I'm going to substitute them by the sine of the angles. So tension 1 that multiplies the sine of the angle of the tension 1 plus tension 2 times the sine of the angle of the tension 2, and in this case I'm going to move weight to the other side, and it's negative, so it's going to be positive, equals weight. Now what can I do? I don't have tension 1, I do have the angle 1, I don't have tension 2, but I have the angle of the tension 2. So if you see, I cannot solve this equation, and also I cannot solve this equation either. So what can I do? This is what I can do, okay? If you see, I'm going to circle this fraction, the cosines, okay? I have the angles, so this is a fraction. Finally, a fraction is going to be a number, and that number is going to multiply tension 1. So I can get the number. I just need to solve this fraction. So I can do it because I already know the value of those angles. So let's do it. Let me get my calculator that is over here. Okay, so let's do it. Remember that the calculator must be in degrees. Okay, so fraction, cosine of the angle 1, cosine of 15 over cosine of 30 degrees equals, okay, and I'm going to press this button over here in order to get a number. Okay, this is the number that I need, and I'm going to save this number in my memory A of my calculator. So shift STO-A. Okay, so that's the number that I'm going to write over here. So tension 2 equals 1.11. I'm just going to write 2 decimals, and this number is multiplying tension 1. So I'm going to write here tension 1. Okay, and I'm going to make this number is in my memory A of my calculator. Okay, so if you see, tension 1 is 1.11 times tension 1. So this number over here, this one over here, this complete number, I'm going to substitute in the other equation over here, because that is what tension 2 is 1.11 times tension 1. Okay, so that's what I'm going to do. So tension 1 that multiplies the sine of the angle of the tension 1 plus, and I'm going to draw it with another color, plus 1.11 times tension 1 that multiplies the sine of the angle of the tension 2 equals the weight. Now if you see, now I only have one variable, that is tension 1. So what can I do? Well, there are many things that you can do. I'm going to show you my way. At the end, you're going to choose which way you want to do. Okay, so what I want to do is a factorization. Okay, so imagine that I have x squared plus 5x. So this is x that multiplies the x plus 5. So what I did here was a factorization. I get the common factor because this term and this term over here both have x. So that's it. That is what I'm going to do in this problem. If you see, this term over here has tension 1 and this one over here has tension 1 too. So what I'm going to do, I'm going to get the common factor, and it's going to be tension 1. Tension 1 parentheses, and I'm going to begin with the multiplication. So this one is sine of the angle of the tension 1 plus 1.11 times the sine of the angle of the tension 2 equals the weight. And I repeat, this is a multiplication. Tension 1 is multiplying this term, and I'm going to have this term over here. Tension 1 multiplies this term over here, and I'm going to get this term above. That is over here. That is just a factorization that is called the common factor. And then this one over here, all this term that is, all this factor that is inside of parentheses, if you see, is multiplying the tension 1. So what I'm going to do, I'm going to move that factor to the other side, dividing. Okay, I repeat, I'm going to move this whole factor because it's multiplying tension 1, and I'm going to move it to the other side, and it's going to be dividing. So I'm going to have tension 1 equals fraction sine of the angle of the tension 1 plus 1.11 times the sine of the angle of the tension 2, and the weight is mass times gravity. Now I have this fraction over here. So with this one, I'm going to get the tension 1. So let's get the calculator. Okay, so fraction mass times gravity. How much is the mass? The mass is 10 kilograms. So 10 times 9.8 over the sine of the angle 1. How much is the angle 1? Is 15. Parentheses plus 1.11, and 1.11 is a number that I already saved in my memory A of my calculator. So alpha A times the sine of the angle 2, and the angle 2 is 30 degrees. Parentheses. Okay, so I press equal, and I'm going to press this key over here, SD, in order to transform that number, and that is the value of the tension 1, and that's the one that I'm going to write. Okay, so tension 1 equals 120.0249, 0249, and the the tension is measured in newtons, okay, because it's a force. So that is the answer of the tension 1. I'm gonna circle it in red, and I need to save this value in my memory B. Well, in another memory. In this case, I'm gonna save it in my memory B of my calculator. Okay, so it's already safe. I'm gonna write over here that is already in my memory B. Okay, so I need to get tension 2. So if you see, tension 2 is the value that I already have in my memory A times tension 1, and tension 1 is a number that I already have in my memory B. So in order to get tension 2, it's going to be so easy because it's going to be alpha A times alpha B equals, I press this key over here, SD, and that is the value of tension 2, and that's the one that I'm going to write. tension 2 equals 133.8704. Remember that this is newtons, and that is the answer of this problem. Okay, so if you see they are the same procedures as dynamics. Okay, the only different thing in this case is that the sum of all forces in both cases, x and y, is going to be 0. Okay, well, I forgot to write over here, but remember that the sum of all forces in y is also 0, because the system is unbalanced and the object moves without acceleration. Okay, so I hope I made myself clear, and I hope I can see you in the next video, guys. Bye bye, take care.